Hello, and welcome to a bonus episode of the Geek Warning podcast. I'm Dave Rome, and I recently travelled across the world to attend a product launch held by Icelandic brand Lauf Cycles. Over the past decade, Lauf has become known as an innovative and surprisingly well-priced brand in the gravel space. Now, they're looking to bring that point of difference to mountain bikes. Lauf's first mountain bike, the Elja, is a modern cross-country machine. The 120mm suspension travel, 29er wheels, and progressive geometry are all common for the category. Less common is Lauf's belief that tyres will continue to trend wider, and that bikes should be as simple as this to maintain. In this episode, I chat with two key people from the company, largely about how a small brand out of Iceland has been able to compete globally. We discuss the new bike and the trends associated with it, and we touch on how Lauf seemingly saw the wide tyre trend in gravel racing coming before anyone else. Okay, so before we get started, our bonus episodes are made for members of Escape Collective. If you're hearing this, you're not on the member feed, which means you'll still be able to listen to approximately half of the discussion, but for the full episode, you'll need to head to escapecollective.com/member. Signing up won't just support our mission of being independent of the industry we write about, but it'll give you full access to all of our exclusive podcasts, written content, and so much more. All right, enjoy it. All right, so with that intro, let's find out who we're talking to this week. Benny, I'll get you to introduce yourself first. Who are you and what do you do with Lauf?
My name is Benedict, called Benny, Benedict Skúlason, full name. I'm the crazy one, I guess. I'm the founder and the original inventor of the Lauf fork that most people know by now. Still at the company, CEO, and still trying to come out with stuff I find interesting and running the company somehow. And
seemingly succeeding.
It's been so far so good.
And Berger, can I get you to introduce yourself as well?
Yeah, so I'm Berger, and I've been with Lauf for around 10 years since I started initially, or 11 even. So I'm kind of Benny's sidekick in R&D. I like everything. I'm his filter, make sure he doesn't do anything too crazy. And just help him realize his ideas, basically. That's my main job.
Very nice, very nice. And are you both engineers by qualification, by schooling?
Yes.
Okay.
Although I think I can't call myself an engineer formally in Iceland, I think. So I took a shortcut. I found out that it was possible to do the masters in 1 year in the US. So in the US, I'm a qualified engineer, but in Iceland, I took the shortcut so I couldn't get the stamp of approval.
Okay. All right. Interesting. All right. And mechanical engineers by trade and all that. And so Benny, I think you told me this previously, but your background is not in bicycles. Where did your engineering career start?
Yeah, I guess my background, all the way in the back, is bicycles, sort of, as a kid and all that. I mean, playing with my bikes and all that, and modifying them and all that stuff. Yeah, since I was a kid, basically, mounting my first V-brakes onto my all that stuff. So after I graduated, my first job was a prosthetics engineer. So I mean, I was always super into composites. So ever since when I was 20 and a bit years old, I worked as a car journalist for a summer or two, and then I managed to get myself a visit to Koenigsegg, the Swedish hypercar manufacturer. And that was where I witnessed for the first time how carbon fiber was used, and I was just fascinated how they were cutting out the chassis of the car with scissors before then laying it up into molds, and I was just I was smitten for life basically by seeing that. So after I graduated, I wanted to get in something composites related, and the only thing in Iceland working with these kind of high performance composites, carbon fiber, was Össur's prosthetics company here in Iceland. So I got a job there, stayed there for a year or so until I got the idea for the fork, and then I just my mind was I was completely absent-minded at work there at that point, so I had to quit and had to pursue this, for good or bad.
And I'd like to think that most people listening to this podcast have probably seen that fork, but Yeah, I mean, can you explain what that first fork was and how it came to be and how long ago that was?
So yeah, this is back in end of 2010, I believe, December 2010 when I came up with the idea. And fundamentally, the idea is like the core or the essence of the idea is like how to prevent like lateral flex from to isolate sort of like the up and down movement of the suspension and like cancel out like lateral movement and thereby this made me come up with the concept of the offset stacks of springs that you see in a fork, like the upper stack and the lower stack, and this like deals with the side loads and like before this you could have like somewhat comfortable bike forks that relied on flex to some degree, like J-shaped, like skinny steel leg forks on old bikes. But you could only take that concept so far because lateral stuff would be like completely out of control as soon as you like introduce some proper flex into it. So it's like basically how to like brace the system from lateral movement.
Sure, I was going to say to add about this upper and lower spring stacks. I think Benny didn't mention that one of the key elements is to have, for the lateral stiffness, to have one stack below and one above the hub. So this
exactly
like the patent is strongly written around this, right, Benny?
Yeah, correct. Actually, yeah. So we got the patent for it. So we applied for the patent in 2011, and this is one of the cores of the patent to have it like one stack below the hub, one above, and this like minimizes the leverage arm towards the system, sort of. And it also means that the springs are like free to move. If you would have the lower stack of springs right above the hub, then the hub would just collide with the springs as soon as it moved. So it wouldn't really work that way. And then you'd have to move it even further up, and then you have like an even bigger leverage arm to the system from the ground. So like a core of the invention is to, stacks of springs placed above and below the hub.
Interesting. Okay. And that started as a mountain bike fork? That was the intention to start with?
We that was the we thought so. I mean, but then I mean there were no gravel bikes back then, or they're not to our knowledge at least. I'm sure there were somewhere, but since there were no gravel bikes, people were basically in Iceland and actually we know that in like Norway and Sweden as well. People were like downsizing mountain bikes sort of at that time, and a lot of people were fitting rigid forks. So this was like, we thought like the happy like in-between solution, but there was sort of like no market for that back then because there were no gravel bikes and the market to downsize mountain bikes wasn't huge, obviously.
Okay, so your first product was in theory a mountain bike product, but it was really a mountain bike product intended to get people gravel riding.
I think it was a lousy mountain bike fork, but still not a lousy fork. It was just good at something else.
Okay. And then I guess, you suddenly became known for those forks, but then when did like a complete bike or a frame pop into Lauf's history? What was the first bike? Yeah,
it was the True Grit. The True Grit actually is our current gravel bike, Seag GL. It's pretty much the same name, just in Icelandic. Seag GL is Icelandic for True Grit. And this was back in 2016 that we launched the bike, 17.
Launched in 17.
Yes, 17. Back in 2017, we launched the bike and started shipping in 2018. And it was never the idea. Okay, depends on how far I rewind. I mean, originally I wanted to like make bikes, but then the idea for the fork came. And then like the plan was never to make bikes around that fork. It was just to make that fork, but then just like through like osmosis or whatever, it's kind of just like happened. We got into like examining all the other gravel bikes out there in detail just to like verify the fit to our fork and all that. And all of a sudden we had designed a gravel bike like unknowingly sort of. So we just took that step in 2017 to actually realize that bike, and haven't looked back since.
No, and then that's Seag GL, that's your current gravel bike, and it came out in 2022, I believe.
Yeah, correct. Yeah.
I mean, it's only today that we're hearing professional gravel racers talk about wanting to run like 2.1, 2.2 inch tires in their gravel bikes and having to adapt their sponsors' mountain bikes in order to do so. But your bike that's already 2 years in the market fits 2.25s. I mean,
Yeah.
Where I'm getting at is like, you're such a small brand out of Iceland. What is it that has led you to be kind of a leading brand as far as innovation goes in some of these categories?
Yes, several things, I guess. I mean, one is that we're just isolated out here and we don't know, at least to begin with. We were clueless what everybody else was doing, sort of just on our little island over here, trying to figure out how to do things.
And with then rough roads and trails.
So then we have the rougher roads. And it's, so you have like the landscapes here. Yeah.
I mean, it's raw. It's very raw. Yeah. It's, I got to experience it, and I mean, it's certainly, more open, more raw, more exposed than a lot of places in the world.
Yeah, exactly. So you have that different angle that this brings to the company. And then I think just fundamentally, I've never liked being a part of like a herd, sort of whenever there is a consensus on something, I start to question, like, really, is it? So why is that? Like rebellion maybe in me on that. So on tire sizes, I've never agreed, sort of. I've never fully understood why gravel bikes should be on such skinny tires, but this was just somehow like the consensus in the industry that gravel tires should be like 40 mil or whatever. It's gradually been creeping up. But I guess like our background, like me and Bergur, we got to know each other through mountain biking, and the biggest like event over here was the Blue Lagoon Challenge, where we used to like race back in the days when we were still just like curious, just getting into the and then like that event, Blue Lagoon Challenge, that's it was called a mountain bike race, but it was really a gravel race, sort of. It's like a modern gravel race. And like through optimization for that race, through like a decade or so, people had like found out that the fastest tires for this race were like 2 inch or slightly wider, slightly above 2 inches. So to us, it was weird that people were all of a sudden riding rougher gravel races on way skinnier tires. It just didn't really add up.
Yeah, interesting. Okay, so you sort of been providing the bike to fit those wider tires before anyone else has, and it kind of sounds like it was effectively so you could have a bike to ride for your local terrain in a sense.
Yeah, absolutely. And just like having the experience going back a decade or so from riding 2.1 inch tires in sort of a gravel race.
All right, well, I mean, that's as good as any segue we'll get to introduce the mountain bike that you've launched, because the mountain bike introduces similar things as far as taking expected tire clearances to a whole new level. So, I mean, what is the bike called? And
Elja, Lauf. So it's like hell yeah, but Elja.
Okay.
Yeah.
And what does that translate to?
Pretty much the same thing as Egla. So,
okay.
It's a slightly more, I think, like slightly more towards like being diligent, but at the same time having like true grit. But it's like perseverance, true grit. Yeah, so it's somewhere there on the spectrum. It's hard, even if you ask an Icelander, they don't really know how. It depends on who you ask, sort of. But yeah, it's roughly the same as true grit.
Okay, all right. And it's, I guess it's your entry into having a complete mountain bike, but it's also, it's kind of a do-it-all mountain bike, as, the cross-country segment has become pretty versatile. And this thing's as versatile as any cross-country bike, so...
You could say, I mean... said before, so it's a little. I mean, it's a simple job we have. We're just photocopying what we did with Seag, sort of. We could say that, but it's like it's doing. Of course, that translates into like completely different things when you get into a mountain bike. The same ideology sort of means different things in a mountain bike than what it does in a gravel bike, but still, it's just like the same concepts sort of being applied to mountain bikes. So like, again, like asking the question like, why are mountain bike tires this skinny? And since we couldn't find a proper answer to that question, we decided that they shouldn't be this skinny.
Okay. I mean, when you say this skinny, I mean, we're talking the current status quo is a 29 by 2.4 inch tire, which is kind of what everyone's cross-country bike fits. You've decided not to make it fit 2.5 inch or a 2.6 inch, but rather there's room for a 3 inch tire in there, if you so wish. and you're speccing the bikes with a 2.6 inch tire from Goodyear.
Yeah, which is still not like and we worked with Goodyear in making that tire because we didn't want like a 2.6 like rough like tire, but we wanted like 2.6 for speed sort of. So it's a cross country tire, but just in a 2.6 width.
Yeah, mesh is a touch narrow, but
yeah, as they tend to do.
Seen, but still a bit voluminous.
Yeah,
but I guess why? Like, what led you to the decision to spec that 2.6 inch tire when everyone else is doing a 2.4?
Yeah, it's sort of, it could almost like reverse that. Why is everybody specing 2.4? It's like, I think like the 2.4 is driven by like conventional aesthetics of bikes. It's because like you have the chainstay reaching out, like sneaking past the chain ring and between the chain ring and the tire. And designers don't want to bring like the chainstay length up like above a certain number, and this makes them like squeeze a 2.4. And if you look at a lot of the current like high-end mountain bikes, they can just like barely fit that 2.4 tire. It's just like there's no wiggle room sort of. But it's like the design of the bike, the Elia. So when we moved the pivot to the place where we wanted to have it, the rear suspension pivot, then it was pretty obvious to us to bring the chainstays up above the chainring. And as soon as you do that, then like why not fit a 3-inch tire sort of? So like I guess like the crucial thing was to fit that 2.6 because we really wanted to be able to have a cross country bike with a 2.6. But then again, I mean, wouldn't it be fun to be able to ride 2.8s and 3s as well?
Yeah, for sure. I guess I'll come back to it because, I mean, that 2.8 3-inch size is something the bike industry's tried before. I'd like to get your thoughts on that. But for now, let's just discuss that suspension design that you came up with. I mean, you talk about every other cross-country bike on the market, and they've pretty much all settled on kind of a cookie-cutter design. You know, they're all using sort of a rocker-driven shock with a flex stay and a main pivot just above the bottom bracket.
Yep.
You kind of didn't do that. You didn't follow anyone else's bikes, but you, I guess, look back at the history books of mountain biking in a sense with what you have done.
So the initial idea actually was to make like a linkage-driven, like single pivot sort of, as you see on like the older Scott Spark bikes and the current Epic and basically most cross country bike out there. Basically, they have the same design. So that was the fundamental. The first design was something like that. But then we just started to question why do we need the rocker arm here? What are we really like gaining from it? What is it like? What value does it add? I mean, it does add value, like when you do the single pivot in a certain way. But then we were like, okay, hey, can't we just address those issues differently and still stick to the simpler, like a true single pivot design, which made us like come up with a design you can see on our Elia. It's like we have like the massive connection box between the left and right side, and pretty beefy structure there and super oversized bearings and all that. So we gain the stiffness that you would otherwise get from the rocker arm just from the shape of the rear triangle itself, sort of. And then we were like, I mean, then sort of, why would we have additional complexity for no good reason, sort of?
Yeah. I mean, what is it about modern technology then that let you return to a single pivot design? Because the bike industry had largely moved on from using that. I mean, for a while there, like more than a decade ago, that was a very popular design, but I guess we moved to different designs, I guess, in pursuit of pedaling efficiency. So, can you explain a bit about...
Air shocks are a huge factor. I mean, without air shocks, we wouldn't be doing it like this, for sure. Because the air shocks, they have like a progressive spring rate. And you can get whatever like progression sort of in the spring as you want, sort of in an air spring. So when you have that in your spring already, which you didn't have in coil springs, then there's no reason to get that progression from like a linkage system. So this was like the first realization. We were like, why? I mean, okay, then why would we sort of? And then we just kept going, down that road sort of, and tried to like to erase like downsides to simple honest, old-fashioned single pivot bikes, sort of.
Yeah. How much did flight attendant, RockShox's flight attendant, play into that decision?
So
like
initially,
the idea of a electronic suspension that handles the lockout for you.
Yeah. So I won't lie. So in the beginning, that was sort of like that was what in my head proved that this was the route to go, because we had flight attendant to take care of like pedaling efficiency for us if needed. But then as the result ended up, with the end result that we have today on the bike, it's no more needed than in any other like linkage driven rear suspension bike, because the kinematics and dynamics of it are pretty much the same. So it's gonna the flight attendant in the end, even though it convinced me to take this route in the beginning, because I thought we would be like losing some functions through skipping the rocker arm. As it turned out, there's no difference there at all. So the flight attendant is just equally amazing on this bike as it is on any other like linkage driven like single pivot rear suspension bike.
Okay, interesting. Yeah, I guess so. We've got single pivot bike, full carbon frame. Weight wise, like where have you come out to?
It's light.
Let's just talk about the frame.
Yeah, so we measured it 1950 to 1960 grams or so. The frame, so that's a fully painted frame with the main pivot installed, not with the shock, not with the like through axle and all that. So it's hard to often compare apples to apples because brands called different things. But this puts it like it's among the lighter cross country bikes. It's among there are cross country bikes in the like World Cup racing series that are similar weight or even heavier, some of them. But we didn't like so this is the way we look at this, is that basically how light can the bike be with this construction and these shapes sort of. And we're super happy with the weight that it turned out to be, because this is like shape driven, because we are not like using brittle high modulus carbon fibers in the bike. So we still, if we wanted to, we could play that card and drop the weight by like 200 grams more. And we could also like do a minimalistic paint, like we just gently like clear coat almost a naked carbon fiber sort of, and that could save like, I don't know, 50 to 100 grams maybe additionally. So like the engineer wise to us sort of, it's like the design is very light and the end result bike is light, and we could even make it compete with the absolutely lightest bikes out there.
But you don't, as a company, you tend not to use those high modulus fibers.
Yeah.
Because you don't like your stuff to break, if I remember what you said before. Is that, I mean, can you go into a bit of detail about that as to, I guess, why you make that sacrifice?
So we choose not to make the sacrifice sort of introducing the high modulus fibers. It's because like it's always a dilemma. I mean, for engineers, it's super exciting to optimize things, to have like a certain goal and just try to get as far as you possibly can with for example, make the bike as light as possible. But when you do that, then you're just optimizing against like the official testing you need to do on the frame, and you're sort of like not thinking a lot about the normal use of a bike, sort of the stuff that happens in real life. You have to look past that sort of, which we don't want to do. And it's like and it's often, I think people often don't realize that this is not just like a slightly different flavor of, or like a slightly less brittleness. It's just like, it's black and white, sort of like the brittleness of standard modulus carbon fiber compared to high modulus. High modulus, just like it's a completely different animal. It can flex like 0.5% compared to 2% of standard carbon fiber. So it can do 1/4 of the deformation, and then as a result, since it is this stiff, you end up using even less of it, because you're looking for like the stiffness of a beam sort of in your shape. So you end up making the walls even thinner. Plus, you have material that is to begin with can only deal with 1/4 of the deformation. So you end up with something that is just like ridiculously brittle compared to if you had made it out of standard Modulus fiber. It's like, it could be like, maybe you need like 1/10 of the impact to break that frame compared to a standard Modulus. So it's, yeah. But I mean, still, I mean, we won't rule out that at some point we'll make like a high modulus frame, because it's not necessarily worse, but I think for most people it is worse. But I mean, if the only goal is to make it as light as possible, then of course it's better, but it comes as a massive cost to chase those like final 200 grams or so.
Sure. Another area of weight on the bike is the lack of, I mean, you tell me, maybe it isn't an area of weight, but the bike doesn't have any internal storage, which is kind of a trendy feature at the moment.
Yeah.
Tell me your thoughts about internal storage.
So, it's like whatever floats people's boats, I guess. I mean, if people like them, there's nothing wrong with that. But it's just, to us, it's so carbon fiber doesn't like being cut because it's made of fibers. And as soon as you cut the fibers, then you need to like divert the loads past the hole somehow that you leave in your frame. So it really like damages your carbon structure like a lot, like cutting a hole into it. So you have to add a substantial amount of weight to reinforce the hole again. So at some point it's like, is it worth it? I mean, it's nice to have maybe like a multi-tool or something in your frame, but if it's making your frame like substantially worse, because I mean, let's face it, you have a carbon frame to begin with. I mean, and the point of having a carbon frame is to make it light. So, I mean, it makes more sense to me maybe on an aluminum frame. One, because aluminum doesn't dislike being cut as much. And two, it's not a frame that is like fighting for like the lowest possible weight anyway, sort of. So,
gotcha.
Personally, I would rather just put my multi-tool in like the bar ends or something else, and then a spare tube in the back pocket. I don't know. Yeah.
Hey, Dave here. This is where we hit pause on the episode. There was plenty more covered, and so if you'd like to continue listening, please head to escapecollective.com/member and sign up. The membership gains you access to our full catalogue of member-exclusive podcasts, articles, and much more. As a reminder, Escape Collective is wholly and solely funded by its members. There's no advertising, affiliate links, or sponsored content. I hope you come back to listen to the rest. Cheers.